Connect the lamp set output socket with the analog light source module with 6-core special connecting cable. Turn on the power switch and rotate the dimming switch to adjust the brightness value of the light source. One dimming switch controls the brightness of 2 light sources. Connect the solar radiometer socket with 4-core special connecting cable. Connect the light pack cable. Turn on the power switch and adjust the brightness value of the light source. You can see the change of the current value of the DC emitter, and the total radiation of the current light source can be calculated through the formula. Connect 2 sets of 12-volt batteries in series to 24-volt and connect them to the off-grid inverter input with 4mm safety test line.
Connect the output of the off-grid inverter with the mount input of the multifunctional measuring instrument with 3mm safety test line.
Connect the output to one of the multifunctional measuring instrument to the 230-volt AC load through a 3mm safety test line.
Turn on the switch of off-grid inverter and the control switch of load lamp. You can view the voltage, current, power, frequency and other parameters of the current load through the multifunctional measuring instrument. Connect the 2 solar panels in series to the elevation plug adapter terminal. Connect the solar photovoltaic output to the photovoltaic input socket of grid-connected inverter with 3-core special connecting cable.
Connect the output of grid inverter to the mount input of multifunctional measuring instrument with 3mm safety test line.
Connect the output 2 of the multifunctional measuring instrument to the power socket through the power line. Connect the light source module with the lamp group output. Turn on the power switch, turn on the grid-connected inverter switch, turn the light source to the brightest, and then check the grid-connected parameter values through the multifunctional measuring instrument. Connect 4 groups of 12-volt batteries in series into 48-volt and connect them to the battery input of wind solar complementary controller. Connect the solar panels in series to the photovoltaic input terminal of the wind solar complementary controller through a 3-core special cable. Connect the analog light source to the light group output. Connect the wind solar complementary controller with the computer through the communication cable. Turn on the power switch, adjust the brightness of the light source, adjust the angle of the solar panel, and check the photovoltaic power generation voltage, current, power, electricity and other parameters through the software. 4 groups of 12-volt batteries are connected in series into 48-volt with 3 mm safety test line, which is connected to the battery input terminal of wind-solar complementary controller.
The LCD screen can display parameters such as battery voltage, back current, and power, photovoltaic voltage, photovoltaic current, photovoltaic power, light control on voltage, light control off voltage, time control time, load current, wind power generation, solar power generation, and load power consumption.
Supply power to the frequency converter module with 4 mm safety test line. The output of the frequency converter is connected to the 3-phase asynchronous motor through the 4 mm safety test line, and the motor is connected in a triangular way. Connect the wind turbine with the wind-solar complementary controller through a 4 mm safety test line. Connect the load output of the wind-solar complementary controller with the LED lamp load through a 3 mm safety test line. The LED load light can be turned on and off through the control switch. Connect the wind-solar complementary controller with the computer through the communication cable. Turn on the main power switch and the frequency converter power switch. Start the frequency converter and check the parameters of wind turbine generator, such as power generation voltage, power generation current, power generation and electricity generation at different speeds by adjusting the speed of the frequency converter. Connect the 48-volt battery to the battery input terminal of the grid-connected inverter through the 4 mm safety test line. Connect the output of grid-connected inverter to the mount input of multifunctional measuring instrument through 3 mm safety test line. Connect the output 2 of the multifunctional measuring instrument to the power socket through the power line. Turn on the main power switch, turn on the power switch of the frequency converter, and start the frequency converter to make the wind turbine in the power generation state. Turn on the switch of grid-connected inverter and check the parameters such as grid-connected voltage, grid-connected current, grid-connected power and grid-connected frequency through multifunctional measuring instrument. According to the above demonstration, connect the cables of wind power generation and photovoltaic power generation, and connect the communication cable to the computer. Turn on the power switch, turn on the dimmer switch, and start the frequency converter to make the wind power generation and the solar power generation work at the same time. Check data such as power generation parameters through software. Move the wiring of our DLWD-GF21 Wind Solar Complementary Controller to Bluetooth Wind Solar Complementary Controller. Open the mobile phone software to connect. Turn on the power control switch and adjust the speed of three-phase asynchronous motor to view the change of wind power generation parameter value from the mobile phone.